Epicon tutorial.
Good day, listeners. Today we want to consider the solution of an initial value problem by using homotopy perturbation method, HPM. So the initial value problem is y prime prime plus 3y prime plus 2y equal to 0 with the initial conditions y of 0 equal to 1 and y prime of 0 equal to 0. So the first thing we are going to do is to construct a homotopy for the differential equation, and that can be done as h of p comma y equal to 1 minus p into y prime prime plus p into 3y prime plus 2y equal to 0. So let's call this equation 2. Then the next thing is to construct a power series solution for y, which can be written as y equal to y naught plus py1 plus p squared y2 plus p raised to the power 3 y3. Substituting that into equation 2, we are going to obtain y naught prime prime plus p y1 prime prime plus p squared y2 equal to negative 3p into, so we substitute into the 3y prime, so that one gives us a y naught prime plus p y prime 1 plus p squared y2 and so on. Then for 2y, so we'll have a 2p into y naught plus p y1 plus p squared y2 and so on. So we want to open the right hand side, we want to open the brackets with p, so that we have y naught prime prime plus p y1 prime prime plus p2 y2 prime prime equal to minus 3. So we take p inside, p y naught prime, so this becomes p squared y1 prime, this becomes p raised to the power 3 y2, then minus 2, p goes inside, we have a py naught plus p squared y1 plus p raised to the power 3 y2. So the next thing we are going to do is the initial conditions. So for the initial conditions, our initial conditions, so this will be written as the first one, the first initial condition, y of 0 plus p y1 of 0 plus p squared y2 of 0 plus equal to, so the initial conditions here will be 1 for the first one, 0 for the second one, 0 for the third one, and so on like that. Then for y prime of 0, we have y naught prime of 0 plus p y1 prime of 0 plus p squared y2 prime of 0 plus. So here we have y prime of 0 equal to 0. So all will be 0, 0, and 0. So continuously like that. So what we're going to do for the differential equation is to equate powers of p. So this has p raised to power 0, and there is no term that has p raised to power 0 here. Therefore, it's going to be equated to 0. Then y prime 1 has y naught. So then p squared, which is y prime 2, has y prime here. So this likewise this goes with y prime 1. This goes with y prime 2. So y prime 2. So continuously like that. That's how we are going to equate the powers of p. So doing that, then the same thing with the initial conditions. Y naught of 0 will go for 1. Y1 of 0 will go for 0. Y2 of 0 will go for 0. The same thing with y prime of 0. So doing that, when we equate according to the power of p, we're going to have for p raised to power 0 now. For p raised to power 0, we have equal to 0 with the initial conditions y naught of 0 equal to 1 and y prime naught of 0 equal to 0. For p raised to power 1, we'll have y prime 1 equal to minus 3 y prime naught minus 2 y naught, comma y1 of 0 equal to 0, then y prime 1 of 0 equal to 0. For p raised to power 2, y prime of 2 negative 3 y prime of 1 minus 2 y1 y2 of 0 equal to 0, y prime 2 of 0 equal to 0. So we can continue like that until we obtain as many terms as possible. Let's begin from the first one. Y prime naught equal to 0. This is the same thing as the square y, the x squared equal to 0. If we integrate this one, integrating for the first time, we are going to obtain the y, the x equal to 0 plus constant 1. So here we are going to apply this condition, y prime of 0 equal to 0. So if you do that, this implies that applying that condition is going to be 0 equal to C1. This implies that C1 equal to 0. So if you substitute that here, so our differential equation, the y that is not here, so the y naught, the x equals 0. Integrating this again, we have y naught equals to 0 plus C2. So this time around, we are going to apply the second initial condition. This initial condition, y naught of 0 equals 1. So when y naught is 1, x is 0. Applying that will give us 1 equal to 0 plus C2. this implies that C2 is equal to 1. So we now come back here and make our substitution into this place. So that means that y naught is equal to 1. So this will serve as the first term of the solution. So we can also go ahead to obtain this one for when p is raised to power 1. We notice that the initial conditions here for the rest terms are 0, 0. So applying the initial conditions will not have any effect on the result. So the best thing is to begin to integrate the right-hand side twice to obtain our y1, to obtain our y2. So by doing that, we just go ahead and integrate and be making substitution of the previous term there. So if you want to do that, that means our y1 will equal to -3, 0 to x, the y not the x, the x minus 2 is here. Y not the x. The next thing now is to differentiate this one. So let's make substitution 3, 0 to x, 0 to x, dx of 1, because our y naught is 1, minus 2, dx for our y1, the entire term here will be 0, minus 2. So integrating that twice is going to give us 2x squared over 2. And with further simplification, give us minus x squared. So let's quickly do that for the third term. So we want to obtain for y prime prime 2. Like I said, we just integrate twice because the conditions are all 0, so it won't have any effect. So we come here for y2. This will be -3, dx of y2. Our y2 is negative, y1 is negative x squared minus 2, negative x squared dx dx. So if we simplify this, integrate, we differentiate negative x squared and then integrate twice, that will result in 6x raised to power 3 over 6 plus 2x raised to power 4 over 12. And simplifying, y2 becomes x raised to power 3 plus 1 over 6 x raised to power 4. So, and the solution can then be collected together as, you can collect the solution together as y0 plus y1 plus y2. And this gives us 1 minus x squared plus x raised to power 3 plus 1 over 6 x raised to power 4. So you can then obtain as many times as possible. Thank you for listening.